Good morning, Year 12 further mathematicians. I hope you're all well. I'm just going to finish off finally Chapter 11 on integration for Year 2 Single Maths Pure. It's to do with modelling with differential equations, which currently modelling with differential equations is one of the most important areas, not only in maths but in real life as well, because it's one of the methods people use to model stuff like this going on at the moment in terms of viruses, etc. Okay, so learning objective for today is to solve differential equations that have been used to model real life situations. I'm gonna go straight into it. So we've got a very, very long example, a lot of words. So we've got water in a manufacturing plant is held in a large cylindrical tank. The diameter of the tank is 20 meters, and the water flows out of the bottom of the tank at a rate proportional to the cube root of the volume. And we're going to show that question. Now this is the bit which we did in a previous subchapter. Sorry, not in a previous subject, in a previous chapter. The one with differentiation, we had to come up with a differential equation ourselves. And this is what they're asking us to do today. So I'm just going to pick on keywords in this, which is water flows out to the bottom of the tank at a rate proportional to the cube root of the volume. So water flows out of the bottom of the tank at a rate proportional to the volume. So water is flowing out of the tank at a rate proportional to the cube root of the volume. Now, any ideas on what that would be just in mathematical symbols? Ignore this, okay? Because I should show that. That's the last thing you're going to write down. Water flowing out at a rate. Okay, so if water's flowing out, for me that's the volume of water is flowing out. So it would be volume on the top, and then rate means with respect to time. So that there is dV by dt. Water flowing out at a rate, volume with time, proportional to the cube root. So cube root of the volume, and because it's flowing out, it'd have to be minus the cube root of the volume. Cube root of the volume, like so. In other words, dV by dt is equal to, and we use some proportional constant minus k cube root of v. Now, this is done to test your understanding, because if I look at this answer there, it's identical almost to this, very similar, yeah? So all they're doing at the moment is just testing your knowledge, because that they don't want people to skip steps, because this would be worth quite a few marks in an exam actually, so there's still a lot of work to do, but we've just worked out dV by dt. Now you need to use something from the differentiation subchapter to work out dH by dt. Okay, and dH by dt would be equal to dH by dV times dV by dt. I knew I had to use a dV by dt because that's given. I've just worked it out, and that's the only other way to work it out. Okay, we know what that is, but what is dH by dV? How can you work that out? Because V represents volume and H represents height. So effectively, they're talking about the volume of this liquid in this cylinder. And volume of a cylinder is the area of the cross section, which would be pi r squared. So pi times 10 squared times by the height h, which would be 100 pi h. And that's volume. I can't work out dH by dV, but I can work out dV by dH. Okay, so dV by dH, based on that, dV by dH would be equal to, differentiate this with respect to h, it's just go to 100 pi. And then can you remember what the link is between dH by dV and dV by dH? It would be 1 over. So that's 1 over 100 pi times dV by dt, which is what I've worked out there, minus k cube root of v. Right. What is, how far away? Not far away. They haven't got v's, they got h's. So I need to replace volume with something in terms of h, which is that something above there. So this is the same as minus k over 100 pi times the cube root of the volume, which is 100 pi h, like so. And then we're almost there. We want to kind of just get the cube root by itself, and we can use sort of rules for surds. This would be the same as, I'll write it over here. This would be the same as minus k over 100 pi times the cube root of 100 pi times the cube root of h. And then we are almost there now. So believe it or not, this is actually done. Minus k cube root of 100 pi over 100 pi times by cube root of h is job done. Because if you look at the show that dH by dt is equal to minus k cube root of h for some constant k. Now that constant k is actually this entire thing there. The only thing that's kind of confusing, because all of this is a constant, k there was a constant. The confusing thing is I've used k there and they've used k in the answer as well. But k just represents a constant. And this number is a constant, because 100 pi is a constant, root 100 pi is a constant, cube root of 100 pi is a constant, and k is a constant. So that is job done, but I've just used the letter k. So that is their k value. And that's it. Okay? Right, let's go on to the actual stuff now, which is part B, to show that. Show that the general solution can be written as the following. H equals brackets p minus qt to the power of 3 over 2, where p and q are constants that we're going to probably find. Okay, I'm going to state the formula that they gave us to show that dH by dt equals minus k cube root of h. Okay, I use this version of it and not my complicated version of it because k is a constant. Yeah, that thing is a constant. So what's the point in having the really complicated version when you can just have a letter? Right, how do we solve these? Well, we separate the variables. We take all of the t's to one side, all the h's to one side, and go from there. But which side do we take them? Because normally we have dy by dx, and if we've got that, we take the y's to the left and the x's to the right. So this one, dh by dt, h's go to the left, t's go to the right. So this would be, kind of want to do this in index form as well. So minus k h to the third. If I took that to the other side, that would be minus to the power of minus a third. So that would be h to the minus a third dh by dt is equal to minus k. and then you integrate both sides. In this case, what do you reckon with respect to? It's normally with respect to x, but this time it'd have to be with respect to t for those to cancel. Right, k is a constant, so when you integrate a constant, it goes to minus kt. And this, integrating h to a power, this is the first bit of integration you ever did. Something to the power of n. Add 1 to the power, divide by the new power. H to the power of 2/3. Divide by the power, so divide by 2/3. And then because we did integration, we have to have a constant. So normally put it on this side, keep it that side, plus c. Right, could stop there. That is a general solution, that's job done. However, they want us in this form. They want us to make h the subject. So let's tidy this up a little bit. 1 divided by 2/3 is 3/2. H. That's better. Make h the subject, so divide by this. So h is to the power of 2/3 is equal to minus k over 3/2 t plus c divided by 3/2. And then how do you make h the subject? Well, remember that bit there means cube root, and that bit there means square. So you have to do the opposite of those to get h as a subject, which is cubing everything and then square rooting everything. So if you did that, this is equal to, again, you could tidy these up, it doesn't actually make much of a difference, 2k over 3t plus, because this is a constant, again, it doesn't actually matter, but 2c over 3. Remember what I said, we are getting rid of the cube root by cubing something and getting rid of the square by square rooting something, so that's to the power of 3/2. And if you look now what we got compared to what we should have had, p and q are these constants. P is that one and q is that one. So that's there p, that there is q. Because remember, q and p are just representing constants, and both of these are constants. Right, one more thing, or two more things. We are going to now, it says initially the height of the water is 27 meters. 10 minutes later, the height is 8 meters. Find the values of p and q. So what was that equation on the previous page? It was h equals p minus qt to the power of 3/2. And now we've been told initially the height, because remember this is actually the general solution. And because they've given us some initial conditions, we can actually work out these unknowns, p and q, like the plus c's normally. So initially the height is 27 meters. So another way of saying that is when t is equal to 0, h is equal to 27. If we substitute that in, 27 equals p minus q zeros to the power of 3/2, which would be 27 is equal to p to the power of 3/2. And remember, that's a square root and a cube. So then to get p by itself, you would do 27, get rid of the square root by squaring something, get rid of the cube by cube rooting something, and that would give you 9. P would actually be 9. And then you use the other bit. 10 minutes later, I'm just going to check to see what the measurement of t, what was t in the question. I'm just going to assume it's minutes. Yeah. So I'm going to say t is equal to 10. 10 minutes later, h has dropped down to 8. So we've got to substitute those in. 8 equals P now is 9 minus Q times 10 to the power of 3 over 2. 8 is equal to, oh, that's simplified to 10Q, take away 9 to the power of 3 over 2. And again, you can get rid of this, so you 10Q minus 9, get rid of the square root by squaring, so 8 to the power of 2, get rid of the cube by cube rooting, so you've got that. 8 to the power of 2/3 on your calculator will be 4 probably. And if you make Q the subject, add 9, divide by 10, you get 13 over 10, which I hope is right. Apparently it is wrong. Should be a half. What have I done wrong? I shouldn't have swapped these around. Okay, so ignore this. That's still a plus 9, that's a minus. Can't swap these around. That's a minus, that's a plus. That's still a minus and a plus. Swap those around and it was wrong. So if you make Q the subject for this, you actually get half instead. That's better. So P was 9, Q was a half. And that's it. That's it. In other words, that formula we had, H is equal to 9 subtract a half T to the power of 3 over 2. Yeah, I shouldn't have swapped those around. That was stupid. Okay. Part D, last thing, is find the time in minutes when the water depth is at a depth of 1 meter. So we've got a formula now. H represents the depth of the water. T is the time. Substitute T. No, that's the thing. Substitute H is 1 in. And we get 1 is equal to 9 minus a half T to the power of 3 over 2. Yeah, the best thing to do is again, that's square root in, so square it. That's cube in, so cube root it. 9 minus a half T to give you a half. T is equal to 1 to the power of anything is 1. So that would be 8 to give you T is 16. So 16 minutes it would take for the water depth to drop to 1 meter. Right, that was a long question. Right, so I'd like you guys now to finish off this this chapter using exercise 11K, which is on page 328. Just do the evens. And yeah, this is the toughest subchapter or chapter in the entire single maths course, and to be fair, it is something which is going to come up over and over again even in further maths. You need to get this right. So if you've got any questions about any of the stuff we've done, it's really important that you ask me, and I can give you as best sort of advice and feedback as I can. But post all your work on class notebook and everything, and post questions on Teams, and that'll be it. Cheers, have a good one.